Now let's ask the question, how do we find local extrema over a compact set? A compact set being a closed and bounded set. First of all, let's define what it means to be closed and bounded. So definition. A set is closed if it contains its boundary. And we call a set bounded if it can fit in a ball of sufficient size. Let's do some examples here. Let's say this guy is a set in R2. Well, he's closed because he has all of his boundary points. Furthermore, he's bounded because I can find a ball sufficiently large that contains him. Right? This is fairly clear. Now, if I change this ever so slightly by making this a dashed line, well then he's no longer closed, but he's still bounded. Now if I fill this in again to include the edge, but if I said, well, suppose D contains this region too, and it goes off forever. Well, now it's no longer bounded, because every ball that I make, however large, there's going to be a part of D that cannot be contained in it, no matter how large I make the ball. So this set is no longer bounded. It would, however, still be closed because it contains its boundary. Now that that's clean, let's consider the question, how do we find local maxima, or even absolute maxima and minima on a bounded set, or bounded domain? So if F is restricted to a bounded domain, how do we find the local maxima, minima, or even absolute maxima and minima? Well, we have a procedure very similar to what we did in Calc 1. Well, first of all, what we'll do is we'll find the extrema in the inside, and then we'll look for them on the outside. So let's write this down. So if we want to find the extrema on a closed and bounded domain, we do the following. First, find the critical points on the inside of D, and then we find the critical points on the boundary. Now the third step is to compare the values. The largest will be the absolute maxima on the domain, and the smallest will be the absolute minima. This seems pretty self-explanatory. So the largest is absolute maxima, and the smallest is the absolute minima. So this isn't a very hard procedure. We'll go through an example in the next video. I hope. Maybe, maybe not. I don't know. I don't know what I'm doing.